Hello everyone, I am Rishabh Vasa, co-founder of Agri Technologies voice and audio company based in Mumbai. I have my co-speaker, my three along with me today. Today we'll be talking about analyzing big data on cloud. We'll talk about BigQuery, BigQuery ML and AutoML tables. I'll spend a minute talking about BigQuery. BigQuery is Google Cloud's enterprise data warehouse. Google Cloud has exabyte of data stored in BigQuery, and customers are able to run SQL queries on petabyte of data. All this is enabled by the serverless architecture of BigQuery, and underlying that is a separation of storage and compute, which has allowed BigQuery to perform really well. So now let's just So Google Cloud largest customer has stored more than 250 petabyte of data in BigQuery, and the largest query being run on are 5 petabyte of data. Now this is awesome data to run analytics on. So now let's just get into my screen and I can just show you how you can set up and use BigQuery. So you just select BigQuery from the cloud console. You can see the screen over here. You can see the project, and here you can easily create a data set. You can name your data set anything. Let's say I'm going to name it as demo data set. I can select the locations over here and I just click on the create data set, and the data set is created. Now I can create table or I can import data using the create importing options. You can import data from your Google Cloud storage. You can upload the CSV or the files. You can also connect your Cloud Bigtable. So let's say we are importing a CSV file today. So we have a data of 50,000 sales records. So I just select that file as a CSV. Here I have already selected the project name and demo data set, which is the data set we just created. We can always change that data set as well, or if you have multiple data sets. Always remember to select the schema and input parameters. It will automatically detect your columns and create the table accordingly. Here I can give that name. Let's say I give this name as a demo table and I create the table. It takes just one import the CSV and create a table into BigQuery. Here, okay. So now the table is created. You will see the name of the table coming here under demo data set. I can just go to that table, and you can see here all these columns which were there in the CSV file are generated and the table has been created. I can see the details about the tables over here, and then I can also preview the table where I can actually see the table. So you all can see the table with the data. There are 50,000 rows that you can see over here, and you can scroll the data. You can also easily run the query on the table. So you can just click on the quick query table. You can easily create a table, or you can select certain columns and run an SQL query. So if I run this quickly, results will be shown. You can also save this query, or you can also save this results in a CSV format. You can export this results. You can also explore the data using the data studio. So there are multiple ways that you can use the data BigQuery and analyze your data using the simple SQL query. Now let's just get back to the presentation. So now, like we saw that there is a BigQuery, and then there is also the power of BigQuery. Now, for example, Google there are a lot of ML and AI data analysis needs to be done. However, when we want to do a machine learning on the data, we see a lot of tasks which are not really machine learning specific. Let's say you create a model in a notebook on a sample data that works well, but if you create a production model, we need to see, we need to write the ETL pipelines for model creation, and then also we need to write the ETL Uh, we need to write ETL pipelines for predictions as well. So now bringing that data to machine learning creates it then very easy. And the bigger headache, however, is that all the policies and governing policies that needs to be managed well. The moment we export the data from the existing data to some other model, it kind of needs a lot of governance policies. So Google Cloud kind of take care of all this very well, and just train a model on a VM cluster outside BigQuery. So that could be a problem for the enterprises as well. But now Google, the BigQuery solves that problem. Now, Google Cloud is solving this problem through a SQL interface to machine learning called BigQuery ML. With BigQuery ML, Google Cloud is bringing machine learning to the data itself through two simple SQL commands. One, you can just say create model, and that will build a model for you within BigQuery. And second, just say ml.predict to use the model and get predictions in BigQuery. All the features you go into the select statement, you can very fast recreate or model the changing feature, and you can also change the model types within that SQL. Google Cloud automates a lot of standard ML tasks like splitting of training and test data sets, or standardizing of numeric features and coding of category features. So with the minimum number of lines of code, you can get a pretty good model. And finally, since this happens in BigQuery, there is no infrastructure management, and all the governance and access policies you define are automatically applied to this machine learning workloads as well. So Google Cloud has extended BigQuery ML to support all these new models that you can see on the screen, which enables you to address most of the machine learning use case you have on the BigQuery data. Google Cloud has added new type of models to BigQuery ML to predict your machine learning models. To address most of the use case you would have for machine learning in BigQuery, specifically for classification and regression models, GCP have added the support of creation of boosted tree using XGBoost, the deep neural network using TensorFlow, and AutoML tables in terms of other use cases. GCP have added support for creation of hundreds of thousands of time series model with a single SQL command, and you can also create product recommendation system using metrics factorization for use case that requires online predictions. You can now export model created in BigQuery ML and use it for online predictions in Google Cloud AI platform as well. So you can use it for serving your own stack and set the stage. So now just let me introduce or welcome Maitri to deep dive more into the BigQuery ML, where she'll take us to the BigQuery ML console and how we can use it.
Thanks, Rishabh, for setting context on BQ and BQML. In case you're planning to build your first application that uses ML, or you've built multiple ML models before and are looking for a way to accelerate your ML pipelines, BigQuery has the power to do all of that with the ease of SQL. So let's head to the GCP console and see how we can implement ML models in BigQuery. Okay, what you're currently looking at is the GCP console and showing the BigQuery dashboard. On the left hand side, you will see all of your projects that exist, and under the projects, you'll be able to see the different data sets. So you can think of data sets as directories which help you organize all of your tables and also give access permissions. Let's open up one of the data sets. You can store your tables, your models under a particular data set. Okay, so to get started to build your first ML model, let's load some data into BigQuery. Like Rishabh mentioned, go ahead and click on create table. You have multiple ways you can load data from. For the sake of this demo, I'm going to pull some data from GCS. I've already uploaded a flights data set, which is an open source data set onto GCS. Let me just give this a name. Okay, so here's coming to the schema of the data set. So whenever you have a data set, you have a table, you would need to mention what are the different fields that are present in it. For example, you would say, hey, this table has airline, which is going to be a string, and all of those different schemas. You can either manually enter this, or you can let BigQuery auto detect it for you. Currently, I'm going to let it auto detect. The last two options that you see, partitioning and clustering settings, are extremely important to use the true power of BigQuery. So what happens is BigQuery lets you store petabytes worth of data, right? But it's important to store them in a way that you, as and when you query your data, you don't end up paying more or reducing your performance. So good practice to do is to partition your tables and chunk them into smaller tables instead of putting all of your data into one large table. This not only gives you better performance, but also reduces the cost, as BigQuery charges you by the amount of bytes that each query queries. Next is the clustering. Clustering is super useful, especially when you have queries where you aggregate particular columns, or you might find a filter by a certain column and you're constantly doing these kind of queries. So what clustering lets you do is it takes all of these data. For example, if I want to cluster by a particular day, it will store all of that data, co-locate them close to each other so that your queries are even faster. You can go ahead and click create table. For the sake of this demo, I've already loaded data. So let me go ahead and show you the data. In order to see it, let's click on the table. Okay, so like Rishabh mentioned, you can just go ahead and hit query table, and that would help you uh, auto populate the SQL query in order to the classic select start query. For now, let me just remove the limit 100, limit 1000 from the query to see the power of BigQuery. So I'll go ahead and hit on run. When you write a SQL query, BigQuery in turn converts it to a graph of execution, which it then parallelizes across its workers. So, based due to the distributed nature and the parallelization capabilities of BigQuery, that's why we're able to get queries real fast. So, irrespective of how large your data set is, and even if your data keeps growing day by day, you can still maintain the same amount of performance and the cost. Okay, let's go just check out what data we have. We have a flights data set, which includes which flight has departed from a particular airport, gone to a particular origin airport, what is the delay in those flights, and so on. Before we get to building our model, the step one to build a machine learning model would be to understand and explore your data. Have you faced issues where you have a large amount of data and you load them onto your Jupyter notebooks and you're waiting for quite a bit in order to visualize that data? Well, you don't even need to step outside of the GCP ecosystem. You can directly explore your data on Data Studio, and you can explore large amounts of data. And the best part is Data Studio is free of cost. Let me, so you can go ahead, click on Explore Data and visualize this data. Let's go to the Data Studio console. Okay, so here we have whatever you query, you will be able to visualize it immediately onto Data Studio. Let's take a look at what our data looks like to get a feel of it. Let me add a chart that will probably tell us the distribution of all the different airlines that are present. Okay, here we go. We can also see what are the different places that these airplanes are departing from. In order for that, let me add a bubble chart. Okay, let me drag destination airport and drop it into the location. So this will give you an idea of which places the airports are a part of the destination airports. Now you can even do more fine-grained stuff, like if you want to figure out where is there more traffic, we can also take airline and put it into our size, and we can figure out the count of how many flights are departing from how many different destinations. This gives you a good sense of where is the traffic and helps you analyze further. Okay, so we do see some fields like delay, which is mentioned. So we can take a look and see whether there's any correlation between the delay and the different destination airports. In order to do that, let's just pull up a area chart and let's pick the time of the year. Let's see if a particular month has more delay than the other. Let me pull up month and put it into the dimensions. Okay, and let me also pull up airline delay and put it into the metrics. Let's figure out the average delay across all the months. Now you'll be able to see that some airlines are peaking during the months of December and some certain airlines just completely stop after July. This way, you'll be able to analyze large chunks of data with absolute ease. You can also further filter it based on certain fields or parameters that you want to check it out. For example, if I know I want to figure out what is the pattern for a particular uh, airline, Southwest Airline, for example, I can go ahead and analyze my data that way. So without even moving out and without loading all of this data into an external uh, BI tool, you can figure that all out with the ease of Data Studio. Now that we have some idea about what our data looks like, let's head back to the console and see how we can build machine learning models with this data. Okay, now we're back onto our console. Let me just show the editor. Okay, so a good practice while selecting data is always to select the columns that you need. Preferably, it's not recommended to do a select star and just look at all of your data. So for now, let's just look at these 5 parameters, which is the month, destination, airport, a few of them, and arrival delay. So let's pick a problem that we want to solve or that we want to predict. In this, I think we can predict and see if there is any airline delay and how much delay is there for different based on the different input parameters. Okay, so this is our classic select statements where we mention a bunch of columns that we want to select, and we also tell which particular table we want to select it from. Pretty familiar, right? So in order to convert this to a machine learning model, all you would need to do is add 3 steps. So let's take a look at how we can take this simple SQL query and make a machine learning model out of it. The first thing that you need to do is you need to give a name for your model. So let's call this simple model, and you need to mention where you want to store it. So we'll be storing this under the flights demo dataset. Second thing you need to mention is what kind of a model you want to build. So we saw this airline delay was a continuous number. So we'll be using a basic linear regression model for this use case. So that's where you mention that, hey, I want to build the kind of model that you want to build. The third thing that you need to mention is what is the column you want to predict. So we want to predict the arrival delay. So we are going to go ahead and mention that as the label. So this is how easy it is to build your model. And let me go ahead and click on run. Okay, so our model has started building. The whole beauty of this process is that when you have a large amount of data or even some amount of data, you might spend a lot of time taking data, writing code to take data outside of your data warehouse even before starting to analyze it. So now you don't have to do all of that grunt work and you can directly build models right into BigQuery. There you go, a model has been trained. Let us go to the model and see and figure out how do we interpret the results of this model. Let me just hide the editor for a few minutes. Okay, so the first tab, which is details, tells you what is the kind of model that you've built, what is the loss matrix, which is used to calculate the gradient descent. In case you're wondering, hey, we never really split the train and tested the data. Well, BigQuery does a lot of things by default. So there is a default random split which is done. In case you want to take a look at what is the data in your training set, you can go ahead and click on them and see it. Okay, so this is regarding what the basic details of your model. This is extremely useful, especially when you build, let's say, 20 different models, and then you want to figure out what are the different parameters that you've used to build that particular model. What you see over here is the training options, and it will tell you what were the default values which were used to build this particular model. Okay, the second thing is training. These are the actual numbers that you see. What has the model, what is the loss of the model across different iterations. So right now we can see that the training loss is 4,000 and something and the evaluation loss is 3,000 something. So this helps you visualize your loss over time. And not only that, you can also figure out how much duration each iteration takes, and most importantly, what is the learning rate for across different iterations. So once we have some training stats, we can also go ahead and see the evaluation stats. Since we're using linear regression, the column that we'll be looking at is mean squared error. So what does this exactly tell you? Well, it tells you the difference between what you predicted and what you should have predicted. So it tells you, it's a measure of how wrong you are, and it squares that value. So the intention of this model is to decrease this mean square error. So you can keep iterating and building a better model and make sure that this particular number keeps going down. The last tab that we see is schema. So again, this is really useful, maybe not immediately, but when you've built, let's say, multiple models, you can go back and figure out what are the different features that you used to build that particular model and what was the evaluation that it gave. Okay, let me just collapse this and go back to the editor. So you might be wondering, well, okay, pretty simple. We built our first model. Now, how do I iteratively improve this model? There are multiple things that you can do. For starters, you can try out different architecture that is present and supported by BQML. One of the models that we can use is a deep neural network regressor. So all you would need to do is remove this and give the model type as DNN regressor. You can also do feature engineering and go ahead, analyze your data, and add more features, remove more features based on your evaluation and training loss. And of course, the most important thing, that is, especially when your model overfits, we might need a larger amount of data. And sometimes we just don't have the compute to accommodate that. So we chunk data and we look at only a part of the data. With the scale of BigQuery, you don't really need to worry about how large your data is. As long as you have data, you can keep adding more data and making sure that your model learns better. Okay, so in summary, you can go ahead and change the type of model that you have. You can also go ahead, train and tweak your different feature engineering. And of course, you can feed in more data and make sure that your model doesn't overfit. Okay, so that's with regards to how you train a model. The moment you train a model, you'll be able to see it under the data set. You can just go ahead and click on it, and you will be able to see whatever stats we saw, the whole training, evaluation, schema. Once you have a model, once you keep retraining it and you have a model that you are satisfied with, we can do the second step, which is predicting our model. Okay, so in order to predict our model, this is also pretty simple. All you would need to do is mention one line which says that, hey, I want to predict ml.predict, and mention which model you want to predict data from. So right now, I've already trained a linear regression model. So we'll be using that to predict. And these are all the different parameters, input parameters that we're giving as an input. So we know that the thing we're predicting is arrival delay. So let me call this as the actual label. And what this model will give me is the predicted label. I will just predict the first 10 rows. Okay, I've hit run. And now we'll be able to see the predictions of our data. As you can see that that was pretty quick, although it was just 10 rows. But now you're able to take this predictions and predicted label and compare it with the actual label. And you can go further, as always, and go ahead and explore this data on Data Studio to see where is your model underperforming, where can I improve, and analyze and further iterate real fast. So this truly gives you the ability to just focus on the ML part of things and not worry about how you move your data, how you deal with big data, and so on. You can just get started, go ahead, tweak all the parameters, tune it, and build the model and truly focus on that. Now that we have the ability to train and deploy and predict a model, what's important for business is we make sure that this data is accessible to them for them to make data driven decisions. In order to do that, we have to showcase this data in a way that business can understand. For this, we can again use Data Studio. Let me switch to the Data Studio tab. Okay, so as you can see here, this is an empty report. You can always add data into your Data Studio and connect them to multiple connectors. There are quite a few number of collectors that you can go ahead and check out. For this particular demo, we'll be connecting data through our BigQuery because that's where we've stored the data. So we'll be picking it from the Frights demo data set and using this data. You can go ahead and add this data to your Data Studio. Like before, I have loaded the data. So I'll jump right to the next step, which is once we have our data loaded, let's make charts out of them. So you can go ahead, like before, we can just add, drag and drop some charts and visualize data. This is the basic one where it shows the distribution of the different airlines. We can also add more fine grained control by giving an advanced filter, uh, which will, and then you can also put a date range control so that if you want to figure out what was between a particular date. And we can also go ahead and add some scorecard to tell us how many airlines and how many flights were present on that particular day. This makes it really easy because then you can go ahead and view this dashboard and share it with people who need to make decisions based on this data. They can quickly interact with this and figure out stats and filter it out, giving them an easy UI to interact with the data. I have made some reports from before, so we can have multiple pages in a particular report, so you can switch between the multiple reports and easily analyze different kinds of data. For example, this tells you the delay across different months, so you're easily able to visualize which particular airport is contributing to what amount of delay and make actionable insights and based on that. Okay, in case you're a developer and wondering, wait, how do I use these reports? How can I use them? You can go ahead and also embed these into your applications that you have. You get a href and you can embed this iframe into your uh, apps too. So another thing which is pretty cool is you might be periodically generating these reports, so you don't need to keep constantly email it to people. You can just schedule an email delivery and it'll go ahead to them. Okay, so that's how you can automate your batch workflow. So you might be having a cron job which runs periodically and generates, does analytics of data and generates report. So you can analyze and you can really make that analytics workflow automated with ease with using BQ and Data Studio. Another thing that you might be wondering is how, if I have a large volume of data and that data is real time data which is streaming in, how can I use that? Let me head back to the slides and show you how we can use uh, how you can go ahead and not only do batch applications but also do real-time streaming applications. Okay, so do you have a mobile application that's constantly sending out data, or are you connected to some IoT based application which is sending out the temperature, pressure, and so on? You might need to monitor them and really take actions immediately and not wait for a larger amount of time, which the batch processing would do. BigQuery also supports streaming ingest, which means that you can directly take your data and ingest it right into BigQuery. Again, high volume of data, you want to analyze it immediately, and you also want to figure out things like trends, patterns, aggregations, not just in batch but also in real time, especially in cases of anomalies that you need to detect immediately and send it out. BQ streaming is super useful. How can you pipeline this? You can take other components like Cloud Functions or Data Flow and put it ahead of BigQuery so that they can ingest data into it. In case you're not using either of them, you can also use your server and directly make it send data to BigQuery by using the BQ streaming APIs. Okay, so I have also created a tiny data simulator which mimics this real-time streaming use case. What it uses is the BQ streaming API that ingests data. As you can see, it's very little code. You just need to create a BigQuery client. You need to mention what table you want to dump data to. You need to give the rows that you want to insert. So this data doesn't need to be, it's something you can create on the fly too. And you can start sending all of this data by using insert rows into JSON directly and stream it into BigQuery. In case you already have like a huge JSON file or CSV and you want to mimic the streaming, you can also use table.insert all, which is another BQ API in order to insert that. Okay, so that's covering two major things. One is the whole batch processing, and one is the streaming processing, where you want to make decisions and you want to make analytics real time. Next, I'm sure you might be thinking, hey, BQ has so many things. I can build my models, I can hyper tune those models, I can parameterize them real quick. But what if I want to do more detailed things? Like, what if I have my own model and I want to bring that, and it might be a little more complex use case, or it might be a model that BQ doesn't currently support. So, how can I bring my existing models and use the scale of BQ and use the streaming power or even the batch processing of BQ? Well, BQ also lets you bring in your own models, which means that you can take your TensorFlow models and upload it onto GCS. Once you do that, from BigQuery, you will be able to import that particular model and then go ahead and use it like any other model. You can do the same old predictions that we saw before. So that's it for how you can analyze your data, build applications real quick, rapidly prototype using BQ. And the best part of it all is you might not need to know extensive amount of knowledge about machine learning, as long as you can put some effort and figure out how do you evaluate the models. And so that way you can build really complex, powerful solutions, that too at scale, with the power of BQML. There are many more things that you can do with BQ, and Rishabh will tell you more about them.
Thank you, Maitri. Thanks for thanks for the thank you, Maitri. Thanks for giving us a deep dive into the BQML and the power of BQML. What all things BQML could do. It's really insightful, and we got to learn like how we can create different models using BQML. Now, as we say, it's not just about like who specializes in writing the complex query, but everyone should be able to harness the power of data. As a business adopt new realities, it's important that employees have access to useful data so they can make informed decisions quickly and produce better business results. For this reason, Google Cloud launched Connected Sheets, a combination of BigQuery and Sheets. Connected Sheets provides the power of and scale of BigQuery data warehouse in familiar context of Sheets. Connected Sheets enables people to analyze billions of rows and petabytes of data in Sheets without requiring specialized knowledge of computer languages like SQL. A live connection between BigQuery and Sheets means your data stays fresh and protected by Google's security architecture, unlike the desktop spreadsheet application that we use. People across the organization can apply familiar sheet tools like pivot charts or the pivot tables or formulas to a big data. It helps quickly deriving insights and reducing their dependencies on specialized analysts. So another example of capability that Google Cloud has brought is its addition of AutoML table to BigQuery. AutoML tables were created to build a best-in-class machine learning models on structured data without any further engineering and without having to think about which network architecture to use. AutoML table searches through a set of architecture and builds the best possible model for you. AutoML tables have been available through its own UI, and now Google Cloud has added it to a model type as a in BigQuery. So just like you create an XGBoost model or a logistic regression model, you can now create an AutoML table classifier through the same SQL interface and very easily build it into your data and like machine learning pipelines. Okay. So AutoML table enables you to automatically build and deploy state-of-art machine learning models on structured data and faster than you could do it by hand. It automate modeling of a wide range of data types, from numbers and classes to strings, timestamp, list, and nested fields as well. What's interesting about AutoML is that you can do all this without any coding work. You can just take an exported CSV file, click a few buttons, wait a while, and get a highly tuned model. And the other end, Google enables you to build a wide variety of different data types and really explores that vast space of possible models and hyperparameters to try to optimize it. So let's see how what's using AutoML looks like. Let's get to my screen where I can show you a small demo. So you can select from artificial intelligence products. You can just select the tables. So this is automatable. You just have to enable it once. There are different regions that you can select. So let's say if I select a European region, for example, I can create a new data set easily. So I'll just name this data set. The data set will be created, and the first step would be to import your training data into the import tab. So and give it a name. So there are you can select the source either from your existing BigQuery data, or you can select a file from the cloud storage, and or you can upload your own file from the computer. So right now we are going to select a file from the cloud storage. I have already uploaded certain files. You can select the bucket, and you can select the file that you want to import, and then you just click on the import, and the data set will be imported. It may take some time considering the file and the size of the file. Once it is imported, it may take some time to, so I can just take you to another data set I have already created, or we can just wait for some time. It gets imported in a second. So what happens, like in the first step, when you can upload the file, you can also update the column type as well as whether it's nullable or not. You can also even click on the different column and see the statistics around the column. So this usually takes some time. So I'll just take you through the existing data set that I have created. So just to give you an idea. So once the file is imported, it looks something similar to this. Here you can select, after, like, you can select the column, you can see all the columns. You can click on the columns to see more data about the column. So you can see the details about the column over here. And after that, you just have to select the target column that you want to model and predict. So here you can see the columns. Let's say I have selected language, I already selected it. And after this, you just have to click on the train model over here. I mean, it's just that easy. After like analyzing data, when you're ready for training, you just have to click on the train model. When you click on the train model, you can put the model name, or you can also put the budget. Budget means the number of hours that you want to train your model to. For example, it could be minimum of 1 hour up to 72 hours. So it's basically the number of hours that you put, the model will be trained accordingly. Here it's all the summary that you can see. It's already been trained, so I'll just show you. It will take some time, and once you put it for the training, you just have to, like, let's say if I put five nodes, that means the 5 hours the model will be trained for 5 hours. You can also have an option to early stopping. So for example, if the model is trained early, it won't take 5 hours of your time, but it will automatically stop training. And then you can just click on the train model. After training the model, it will take the amount of time that you have put there, let's say 3 or 5 4 hours, whatever you put. And then, for example, and then you will notice that once it's done in the models, you can see the model is being created, and this is how it looks. You can go into the evaluation. Right. So, like, for I've seen, if you are familiar to ML, you would have seen this kind of data or data which is shown over here. So, for example, you can. So, best part is, like, in this case, automatable automatically figures out that which training model it should apply, or which. And you can see all this data over here. You can see the model. You can select the model. If you have multiple models, it will show you that what time it was trained and how much time it took to train. And then you can also you can export this data as you want. So here, from export prediction on dataset, you can actually export this prediction. So once this is done, you can actually go to the final tab, which is test and use tab. Now this is like basically where you deploy the model and get the prediction. There is even an editor in the browser that will make a request to your endpoint, so that so that you don't need to set up a local environment to make these calls and try and test out your endpoints. Also, there is an option on top of page to toggle between online predictions and batch predictions, or you can export your model, as we said, or you can also, it allows you to upload a CSV file, or you can point to a BigQuery table and get a prediction results on the entire table or a file, so that you can do it from here. So here you can select the file, or you can just select the BigQuery table that you have, or the data. Considering amount of time it takes to use the AutoML table, it enables you to achieve a much higher level of model performance than you could really do manually. So let's switch back to my uh, presentation. So if you have structured some structured data, or you think you want to do some machine learning, use this as an excuse to try out AutoML table. AutoML tables, it's very easy to use. Like as we saw, it's just like user interface you have to use, and like in 5 to 6 steps you can actually create your model. And right. So there are different kind of use cases which are being used by industry now, that are being used by the companies as well. To give you an example of the most popular use case, that let's start with the retail industry. The use case we are seeing are creating product recommendation system to send product through emails, which are personalized for end user, and calculating the propensity of purchase or propensity of click on an asset for each customer, and again using it for marketing campaigns. If you want to forecast demand of a particular product category by store, by region, with the time series, you can now do that in a single SQL command and use it for better merchandising or supply chain optimization and things like that. Similarly, if you want to predict if someone is going to subscribe or if someone is going to churn, or you can just take a machine or take some marketing action accordingly. All these use case now can be solved through BigQuery ML, and that's the new feature that GCP has added. To walk you through an example, a lot of customers or brands are joined. They have a lot of multiple data which they collect of their customer through online and offline model, or different sources, to create a customer's 360 profile in BigQuery. Now, this 360 profile in primarily considered behavior data, like the transaction data or the demographic data. We can use all this data together to create a set of customer segments right within the BigQuery by using k-means clustering, and there are companies which are doing it, and they have millions of and hundreds of customers data. So once you have those data, you can build a recommendation system in place and run personalized campaign to each of these customers. Again, all this is you can do staying within BigQuery and using BigQuery ML for your machine learning task. So like there are a lot of new things which are being introduced by BigQuery recently. So some of them are like BigQuery Omni or Data Q&A and BigQ plus Looker. So BigQuery Omni, what like so if you have heard about BigQuery Omni, now you can. So what BigQuery Omni does is you can now bring multi-model cloud analysis to your data within BigQuery Omni. So BigQuery Omni is a flexible multi-cloud analytics solution that lets you cost-effectively access and securely analyze the data across Google Cloud, AWS, or Azure, which is coming soon now. So without leaving, and you don't have to leave your BigQuery interface. So using the standard SQL, the same BigQuery and the same BigQuery API, you will be able to break down the data silos and go into the critical business insights from a single pane of glass. And because of BigQuery Omni is powered by Anthos, you will be able to query data without having to manage the underlying infrastructure. That's one of the very powerful new features that BigQuery has launched. There is another very interesting launch has been by in BigQuery is the data Q&A. Now, data Q&A is a natural language interface for analytics on BigQuery data. Now, in a private alpha, data Q&A helps enable your business users to get answer to their analytic queries through a natural language question. Like without burdening business intelligence team, they can naturally talk to their data. This means that a business user, like a sales manager, can simply ask a question on the company's data set and get the results back on the same way. So data Q&A is to make it easier for non-technical users to access the data and insights they need through natural language understanding techniques. So all while machine learning, all the maintaining the business and governance and security controls is taken by the BigQuery. The data Q&A is based on the analyze system developed at Google Research. So Analyzer uses semantic parsing of analyzing and exploring data using conversation. That is like doing the entity and intent recognition. The mapping of underlying business data set and the data Q&A that enables you to conversationally analyze and petabyte of data can be stored in the BigQuery. Yes. Also, in terms of pricing, if you are a flat rate customer, you can use flex slots. You can use your slot as there are no additional charges each time you build a model. And if you're using AutoML tables or a model type which uses Cloud AI platform in the backend, Google converts those resources into the slot and price parity if user is using a BigQuery on demand. So if you want to learn more about BQ, BQML, AutoML tables, there are ample of resources and documentation and tutorials available. Here are some of the links. You can go through them and know more about it. Since it's a vast topic, we try to cover it in a very short span of time. You can go through these things and learn more about it. Thank you very much. This comes to an end, and I hope you like to talk. Thank you.